Okay, we have the problem number 17, an absolutely simple problem. So we are given simplify square root of 512 and express in surds from. So what do we do when we are given some problem like this? Is essentially very simple. Okay, you have to find out all possible factors of the number called 512. So what we do is let's find out 512 all factors of it. So we go to 2 times 2, you're going to get 4 carry over, you're going to get 5 1 carry over, you're going to get 6 256 times 2, you get 512. So we do it over by 2 again, so you're going to get 1 and then 2 and then 1 is remaining, so 1 goes over there and then you're going to have 16. Okay, I think I need to demonstrate this technique a bit more in detail and a bit more slowly so that people can catch it. So you're going to have 512 here, 512 and 2 what happened to my number? Okay, that's 2. Okay, 2 times 2, you're going to get 4 and 5 minus 4, you're going to get 1, and 1 is going to get carry over, and then you're going to do 1 and 1, which is 11. So 2 times 5, the nearest number you're going to get is 10. Nearest smaller number or nearest number lesser than 11 is 10. That is 2 times 5. So 11 minus 10, you're going to get 1. So 1 gets carried over again, and 1 and 2 makes 12, and 2 times 6 should be 200, and that means 12. So the same thing we do repeat it here. So you're going to get 2 times 1 is 2, 2 times 2 is 4, which is nearest but slightly smaller than 5. And you're going to have 1 remaining, and 1 we write that over here, and 1 and 6 is 16, and then you're going to end up with number 8. The same thing we do it over here. So 2 times 1, you can't do it anything here because there is 2 times anything gives you a 0, but that's of no use for us here. So we consider 2 numbers together. 2 times 6 is going to give you 12, and 2 times 4 is going to give you 8, and 2 times 3 and 2, and 2 times 1 and 2, that is 1 remaining, and 1 carries over, and that you're going to get 16, 6, and 2 times 6 you're going to get 12, 2 times 8 and 2 times 4 and 2 times 2. Very simple. Okay, let's count how many number of 2's that we have here. So what do we have here? So we have 1, 2, 3, 4, 5, 6, 7, 8 and 9. Okay, so what we have here is quite simple. That is square root of 2 to the power of 9. That's because by the way, this symbol that I wrote, okay, let me write is b 512. 512 is 2 times 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 2. Okay, so 2 to 2, 2 to 2, and 2 to 2. So there you have it, 2 to 2, 2 to 2, and 2 to 2. So that's 2 to the power of let's write it like this: 2 to the power of 3 multiplied by 2 to the power of 3 multiplied by 2 to the power of 3. Okay, very good. Now you can do these simplifications in a number of ways. Okay, we can do it in so many different ways. I'll first demonstrate a simple way of doing it. Okay, let's have a look. Okay, let's take 512 here, and we're going to have then 2 power 3, 2 power 3, 2 power 3. So you notice that these two are multiplied, so that essentially square root of 2 power 3 whole square multiplied by 2 cubed, and this 2 cubed, what do I write here is 2 power 3. This whole thing is 2 power 3 whole squared multiplied by square root, or under the square root multiplied by square root of 2 cubed. Essentially, that is so simple. Now what do we have from here then on is essentially you're gonna have these two cancel out here. You're gonna have this 2 and this 2 cancel out with each other, and that leaves us with a quite a simple solution, which is 2 to the power of 3 and multiplied by square root of 2 power cubed. So essentially we do the same thing again. 2 to the power of 3 multiplied by 2 square, 2 times 2 times 2. So these two put together is going to be 2 to the power of 2. That's going to be square root of 2 square multiplied by 2, which again simplifies to 2 cubed multiplied by square root of 2 squared multiplied by square root of 2. Well, to square root of 2 squared is nothing but 2, isn't it? 2 cubed multiplied by 2 multiplied by square root of 2. So what do we get? So we get that's the power of 1 when we add these two, because the bases are the same. So when we add, we get 4. So you get 2 to the power of 4 multiplied by square root, which is 16 times square root of 2. Alright, that's your answer. Another way of looking at it is 512 is to look at any other number which is a multiple of 500, which is a multiple of 512, whereas at the same time it's also a square root. Alright, which also as in square number can be squared to give up something which is a multiple of 512. So what do we do in that case is essentially 512. What we do, we look at these numbers. So look at this number 256. You can also look at the number 64. You can also look at the number 16 and 4. All these are square roots. They have perfect square roots, isn't it? They are perfect squares. That means you get 16 squared, so that's 8 squared, and you get 4 squared, and you get 2 squared. Look at the number which has the maximum 1. So that's the maximum. So we consider the 16 squared here multiplied by the remaining number is 2. So it's just 256 multiplied by 2 gives you 512. So what I then do is, instead of writing 16 squared, let me demonstrate it by writing 256 here multiplied by 2, which then essentially is square root of 256 multiplied by square root of 2, and square root of 256 is as we all know, it is just 16 multiplied by square root of 2. Again we end up with the same answer. You can do in the same kind of methods again. Let's demonstrate it using 64 here, for example. For square root of 512, square root of 512 is, if you would like to consider 64. Okay, let's consider 64. 64 times 2 times 2 times 64, that should give us 512. So what is it? That is essentially 512 is 64 multiplied by 2 times 2 times 2, which is 2 times 2 times 2, and that's gonna end up giving us square root of 64 multiplied by 4 times square root of 2, which is square root of 64 multiplied by square root of 4 multiplied by square root of 2. That's 8 times 2 times root 2, that we are going to end up with 16 root 2. Again the same answer. Alright, 16 square root of 2. Okay, we come up with the next problem in the next video.